Now we want to talk a little bit about non-uniform circular motion, when an object moves in a circular path with changing speed. First, let's do a quick review of uniform circular motion. This is a toy airplane, and we're going to have it on a string, like my little blob on a string here. And we're going to use the string to swing it around over our head. So where would the string be if this is uniform circular motion? Can you draw in the string here if this is uniform circular motion? The string has to go to the center of the circle because there can't be any force tangent to the circle. If there's a force tangent to the circle like this, our airplane will go faster and faster and faster as it goes around. If there's a force tangent to the circle like this, our plane will be slowing down as it goes around this circle. So if this was uniform circular motion, there can't be any tangential forces. All the forces have to be in the radial direction. And the string, therefore, has to go to the center of the circle. Now let's think about non-uniform circular motion. You want your airplane to go faster and faster and faster as you're swinging it around over your head. So what do you do with your hand? When you're swinging that around, what does your hand do? It makes a circle, doesn't it? It moves in a circular path. And the reason it does that is because the string has to make an angle like this. And your hand is over here. And when you move your hand in the circular path like this, the string is always out in front of the airplane. So we could break up our tension. If we have a tension in this string, we could break up that tension into a component that's in this direction. I'll use green for my tension tangent, and I'll use blue for the tension radial. We can break up the tension into a component that's tangent to the circular path and a component that's radially inward towards the center of the circular path. This one, we know what it does. The component in the radial direction just changes the direction. Changes the direction as the object swings around, and it does not affect the speed at all. The radial component of the force keeps our object moving in a circular path, but it does not change the speed. And our tangential component changes the speed of the object, but does not change its direction at all. So the force that's in the radial direction causes radial acceleration, and the force in the tangential direction causes tangential acceleration. And we know what that radial acceleration has to be if our object is moving in a circular path. The radial acceleration has to be acentripetal. The centripetal acceleration v squared over r. Let's talk about centripetal force and the net force in the radial direction. So I have an object here, and it's moving around some center point, and we give it some initial velocity, and there's some net force in the radial direction. If the net force in the radial direction is greater than the special value mv squared over r, what's going to happen to our object? It spirals in. The force pulling it in to change its direction is too big for circular motion. So our object ends up spiraling inward like this. If we have our object moving with speed v and there's a net force in the radial direction, and the net force in the radial direction happens to be just right, and it equals the special value mv squared over r, what happens to our object? Circular motion. Our object moves in a circular path. And what happens if we have our object has some velocity? There's a net force acting on it in the radial direction. What happens if that net force is too small? Too small for circular motion. It's less than the special value we need for circular motion. What's our object going to do? Spiral outward. So you can see that the net force in the radial direction has to be just right. When it has this special value, mv squared over r, when the net force in the radial direction equals the mass of our object times centripetal acceleration, we have circular motion. If the force is too big pulling on it for circular motion, it spirals inward. And if it's not strong enough to keep it moving in a circular path, the object spirals outward.